Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Mewa Digital Hub channel. And likewise, today will be different than any other day. So we'll look at paper 3 work, that is practicals. Right. So we will look at KCSE 2024 paper 1. The topics that are usually tested in exam, how they tested and how they answered. And then we then looked at paper 2. And lastly, today we're looking at paper 3. Okay, in the next sessions, I might complete paper 1 and paper 2, and also tackle one mock paper if time allows us, or just continue with another topic. Okay, so click on that subscription button and also click on that notification icon so that Mewa channel can still exist and reach to many students as possible. Okay, and also don't forget to subscribe to my other YouTube channel, which is based on maths only, which we refer to it as My Mastery Tutor. My number is 0797550885, but don't call me during the night time because I'll be sleeping or I would be with my wife. Okay, with that all, let's start the session. So usually paper 3 work includes many things. It includes topics like titration, where we have back titration, we have direct titration. Okay, the indirect one basically is the back titration. We have other types of titration, but these are the two main titrations that you as a student are taught or will be taught in case you're in Form 3 or in case you're in Form 2. So, okay, so but titration is the key concept there. So it's mostly about moles, how to calculate for moles, how to calculate for molarity, and etc. And then we have rates of reactions, and we also have electrolysis. But rates of reaction also includes enthalpy change, energy changes, and etc. Okay, and then we have solubility of substances, and other topics are also included in paper 3, but these are the main ones that you need to study for your KCSE if you are currently in Form 4. But I want to start with this session, qualitative analysis, because this doesn't miss in any of the papers. Okay, and it's basically tested every now and then. So let's start the session. So qualitative analysis is mostly about testing for two things. You either test for the cations that are present within a substance which you don't know, and most of the times you just be given a substance which you call it maybe substance X or substance Y. You don't know the name of that substance. Okay, you don't know which cation it is and which anion does it have. So for you to know that substance, we therefore test for that substance. So we're basically just testing for the cations and also testing for its anions to give you the exact name that is there. So let's continue then. So let's continue from there then. So testing for cations. So when you're testing for cations, basically you should know how to test for calcium, how to test for other ions. But let's start with the calcium part. So if you want to test for calcium, usually you test calcium using two substances. You either use sodium hydroxide or aqueous ammonia. One of them is just aqueous. So aqueous sodium hydroxide or aqueous ammonia. Usually both of them will form a white precipitate with calcium. So for sodium hydroxide, it will form a white precipitate which will just remain to be soluble even in excess sodium hydroxide. And the aqueous ammonia also, it says no precipitate, but usually there is still very slight white precipitate. Okay. Then we have calcium ions. Now this just gives you the reason why it doesn't form soluble solvent or soluble solution, Is because if you take calcium and react with hydroxide, it gives you calcium hydroxide, which is a white precipitate. And most of these bases are insoluble apart from the group 1 elements, which is sodium and potassium. So the precipitate is not soluble in excess of ammonia or sodium hydroxide. So that's one thing that you should know. So the test of magnesium and calcium, they have similar tests, and they give you the similar result because both of them, they don't dissolve in excess of ammonia or sodium hydroxide. So the only way to distinguish between magnesium and calcium is using a flame test. So for magnesium, when you usually burn it in air, it gives you a white blinding flame. For the calcium one, it gives you an orange flame of some sort. Okay, that's the only way you can test it, by the way. But now, if you test for calcium with sodium hydroxide or ammonia, you don't know if it's either calcium or it's magnesium because it gives you the same results. So testing for cations, just like we said, with the calcium one, you'll observe a white precipitate. Okay, so white precipitate. Okay, now there's lead and there's zinc. So this is another aspect that you should know. So if you look at it, if you look at for the sodium hydroxide, white precipitate is observed. Okay, and then you go to another observation. So basically, if you put any of them, it gives you a white precipitate. That's automatically. It's an automatic thing. So either you put calcium into sodium hydroxide or lead or zinc, it will obviously give you a white precipitate. So both three of them give you a white precipitate. But now to distinguish between lead, zinc and calcium, the only way to distinguish them is to add excess of sodium hydroxide, because if you add sodium hydroxide into calcium, it gives you a white precipitate. If you add sodium hydroxide into lead, it gives you a white precipitate. Also zinc, the same way. But now if you add excess sodium hydroxide into calcium, it still form a white precipitate, but for the lead and zinc, it will dissolve. The reason behind it is because lead is usually amphoteric, or zinc also as well. So in case that white precipitate changes to become soluble at the end, it means that lead or zinc is present. Okay, so that's why it's written here white precipitate which is soluble in excess, giving a colorless solution. But if it's if the white precipitate still remains to be white precipitate even in excess of sodium hydroxide, basically just know that it's calcium or magnesium. Now for the aluminium ions. If you test using sodium hydroxide, it forms a white precipitate but it's soluble in excess. But if you use ammonia solution to test aluminium ions, it gives you a white precipitate which is insoluble in excess, because aluminium doesn't give you a complex ion when it reacts with ammonia. The only ions that give you a complex ion is just zinc and copper and cadmium. But just to be on the safe side, just know it's zinc and copper. So zinc and copper basically it forms a white precipitate when you add ammonia solution, but when you add excess ammonia, it usually dissolves. But for aluminium, it just dissolves in excess sodium hydroxide, but not in excess ammonia solution. Okay, the reason behind it is because aluminium is amphoteric. So if you add it in excess, it basically acts as as an acid. So therefore it reacts and gives you a soluble solution. So it gives you a complex ion of hydroxide. Okay, so therefore excess sodium hydroxide, aluminium hydroxide dissolves in excess sodium hydroxide, but not when you just put a fused sodium hydroxide solution. So white precipitate is formed but soluble in excess. For the zinc ions, usually form a white precipitate when you add sodium hydroxide, but when you add in excess, it also gives you a colorless solution, which it dissolves at the end of the day. If you add ammonia solution to it, the white precipitate dissolves in excess. So basically it forms a white precipitate with both, but soluble in excess of sodium hydroxide, of either sodium hydroxide or ammonia solution. The reason why it dissolves in excess ammonia solution is because it forms a complex ion, which we call it as tetraamine zinc. Okay, but just know that zinc, it dissolves in both excess sodium hydroxide and ammonia to give you a colorless solution. For the lead ions, basically it's soluble in excess sodium hydroxide, but not soluble in excess ammonia solution. So I think you need to rectify there, and this is very wrong. Okay, so it shouldn't be soluble. Okay, it should be insoluble. So I'll rectify that part for you. So now let's enter another one. So just know that it's insoluble in excess. For that is for lead ions, because I haven't heard that if it forms a complex ion with ammonia solution. So for iron 2 and iron 3, okay, iron 2 and iron 3, in this it forms a white precipitate even if you add excess sodium hydroxide or ammonia solution. But now it gives you a distinguishable color. It doesn't give you a white precipitate like other ions. So for the iron 2, it usually gives you a green precipitate even when you add aqueous ammonia or sodium hydroxide. But for the brown, for the iron 3 oxide or for the iron 3 ions, it gives you a red-brown solution when you dissolve it in either excess ammonia, in either ammonia or sodium hydroxide, even when if it's an excess or limited solution. Okay, so just know that both of them are insoluble, and one, which is iron 2, gives you green, but if you leave it, it might get oxidized to form iron 3, which will then change its color to brown. So just know iron 2 gives you a green precipitate, iron 3 gives you a brown precipitate or red-brown precipitate. For the copper ions, if you test using sodium hydroxide solution, it forms a light blue precipitate even if you add in excess of sodium hydroxide. It's insoluble in excess, okay, but it forms a distinct color which we refer to it as a light blue color. Okay, so it's a light blue precipitate. But now when you add it in aqueous ammonia solution, it will form a blue precipitate when you add ammonia solution into it, but when you add in excess of ammonia, then the precipitate will then become a deep blue solution. So the copper hydroxide will tend to dissolve in excess ammonia solution, giving you also again tetraamine copper. Okay, so these are just conclusions for different cations. Okay, so for the ammonium, so ammonium, if you just add sodium hydroxide in it, it won't give you much effects because ammonium usually dissociates itself because of the excess heat that's there, or because of just the reaction that takes place there. So ammonium dissociates to give you ammonia, because ammonium is usually unstable, so it doesn't stay put. For the calcium, or for the effect of aqueous ammonia, there's none, so that's something that you should know. For the calcium part, it usually forms a white precipitate which is insoluble in excess, and also aqueous ammonia slightly soluble, but still is insoluble. For the copper 2 ions, but now there won't be any precipitate in aqueous ammonia, because somehow soluble, somehow not soluble. So I won't say that much about calcium when you react it with aqueous ammonia. For the copper 2 ions, it forms a light blue precipitate which stays to be insoluble even if you add excess sodium hydroxide, but for the ammonia, it's soluble in excess, giving you a dark blue solution. For the iron 2 ions, which I've just said it forms a green precipitate even in excess in both aqueous ammonia and also sodium hydroxide. Ion 3, it forms a red-brown precipitate insoluble in excess of aqueous sodium hydroxide and also aqueous ammonia. And then we have lead, which forms a white precipitate soluble in excess sodium hydroxide, but it's insoluble in excess aqueous ammonia. For the zinc ions, it basically forms a white precipitate, but it's soluble. Okay, just know that it is soluble in excess. Okay, in excess sodium hydroxide and also aqueous ammonia. So basically you've understood that. Okay, so just know this basic thing in case they ask you in the exams, and most of the time they'll ask you. So for the lead, aluminium, should be written like this: aluminium, zinc, they're soluble in excess sodium hydroxide. In excess sodium hydroxide. Okay, for zinc and copper, they're soluble in excess ammonia. So this is something that you should know, and in case you've been asked in the exams. So now there's something called halide test, which includes chlorine, bromine, and iodine. So basically we're now entering the anion test. So if you want to know if this solution contains a chloride ion or a bromide ion or an iodide ion, you basically use some reagents to test for it. So for the first part, we usually use acidified silver nitrate. Now for the acidified silver nitrate, the test usually gives you a white precipitate of silver chloride. Okay, as of a white precipitate of silver chloride, and a cream of white precipitate of silver bromide, and a yellow precipitate of silver iodide. So if it's a white precipitate, just know that there's a chloride there. If it's an off-white precipitate, just know that there's a bromide there. And if it's a yellow precipitate, just know that there is an iodide in that solution. So basically, if you use silver nitrate, it will form a white precipitate with chloride ions. It will form an off-white precipitate of bromide ions, and it will form a yellow precipitate of iodide ions. Then we have the sulfate ions. Okay, the sulfate ions, basically if you want to test them, you use the barium chloride test. Now barium chloride, if it reacts with the sulfate ions, it gives you a white precipitate. The reason behind it is because the chloride is displaced by the sulfate. At the end of the day, you'll form a barium sulfate, which is a white precipitate. So if you take barium chloride and react it with any solution, any solution, okay, any chemical substance, that is, if it forms a white precipitate, just know that substance contains sulfate ions in it. Okay, otherwise you won't form a white precipitate. How can you form a white precipitate? Okay, so any soluble sulfate will give a white precipitate of barium sulfate. So the test is made in the presence of dilute hydrochloric acid to remove any carbonate or sulfate ions which might be present, and these ions will also produce a precipitate which will confuse the results. So know that in advance. Now for the carbonate ions, we use acid test. Okay, so basically any carbonate usually produces carbon dioxide when you add a dilute acid, be it hydrochloric or nitric or sulfuric. So a carbon dioxide gas will always be produced. So, and how do you test for that carbon dioxide? Is when you pass it through lime water, which will eventually become a white precipitate. The reason behind it is because carbon dioxide is an acidic gas, Therefore, when it reacts with lime water, which is a basic solution, you'll tend to get a salt and water, and that salt is a carbonate. Okay, so a carbonate will always produce carbon dioxide when you add a dilute acid. So eventually you'll see an effervescence. And how do you know if that gas is carbon dioxide or not? You pass it through lime water. If it forms a white precipitate, just know that is carbon dioxide, and eventually that substance is a carbonate, has carbonate ions in it. Okay. Now, just for anions, this is just a summary. So if you want to test for carbonate, you add dilute acid. If that dilute acid gives you an effervescence, just know that carbon dioxide is produced and it has carbonate in it. Okay, if you want to test for chloride ions, acidify it with dilute nitric acid, then add aqueous silver nitrate. So if it forms a white precipitate, just know that that solution contains chloride ions. Okay, for the nitrate part, you add aqueous sodium hydroxide to the solution or to the substance, and then aluminium foil, warm carefully, so ammonia will be produced at the end of the day. Okay, for the sulfates, use acidify it with dilute nitric acid and add aqueous barium nitrate. If it forms a white precipitate, then just know that that product is barium sulfate. So eventually you'll know that that first product has sulfate ions in it. So test for gases, sulfur dioxide. Again, how do you test for sulfur dioxide? The gas, usually when you pass it through aqueous acidified potassium, it will change the acidified potassium dichromate 6 from orange to green. So if you change it from orange to green, just know that that gas has sulfur dioxide, or sulfur dioxide is produced from a certain reaction that gives you sulfur dioxide. Okay, so just take two solutions, react them. If you tend to see that sulfur dioxide is produced, for you to test for sulfur dioxide, you just pass it through acidified potassium dichromate 6, which changes from orange to green, to test for the presence of sulfur dioxide. Okay, test for hydrogen gas. I think that's clear. If you want to test for hydrogen, what do? You just insert a burning splint into the test tube that emits out hydrogen. So the hydrogen usually produces a pop sound with the burning splint. So eventually you'll hear a squeaky pop sound from it. Now, if you want to test for oxygen, take a glowing splint and not a burning splint. Take a glowing splint and insert into that test tube which you think or which you suspect it to have oxygen in it, or to produce oxygen. So if that glowing splint relights itself, then basically that gas is oxygen itself, because oxygen supports combustion and also burning. Common methods that we have: magnesium ribbon is the one, that's the first picture that you see, and then we have zinc powder, we have iron fillings, obviously, we have aluminium foil. Aluminium foil is basically an item which anyone can know, and then we have lead. Okay, and lastly we have the copper tannings.